The Jurassic Period, or simply the Jura, is perhaps one of the most interesting times in Earth's history.
After watching the famous movie Jurassic Park, an average person might think Earth was only full of T-Rex.
But in reality, it was not entirely like that, even though the Jura is called the Age of Reptiles. First of all, it is necessary to confirm that the Jurassic Period, the second stage in the Mesozoic era.
It was very long and complex, starting from 201.3 million years ago and lasting about 56 million years.
The name Jura comes from the Jura Mountains in Switzerland and France, where the first fossils were discovered.
The Jurassic Period is divided into 3 stages. The first stage lasted from 201.3 to 174 million years ago.
This is called the Lower Jura. At that time, life was recovering after the Triassic-Jurassic extinction event. This event caused about half of the animal species on Earth to disappear, leaving many ecological niches empty.
However, the hot and humid climate of the Jura helped life recover quickly across the entire planet. The oceans and warm seas were filled with species like ammonites, belemnites, fish, and marine reptiles. On land, reptiles, including dinosaurs, quickly occupied the ecosystems left vacant by the previous mass extinction. During the evolutionary process, some reptiles developed wings and flew into the sky, marking a new era. The early Jurassic marked the golden age of reptiles, with hundreds of dinosaur species appearing on the planet. They lived on all continents, including Antarctica, which was much warmer than it is today. Some species reached incredible sizes and proportions, becoming the largest land animals to ever walk the Earth, while some others evolved into strange and terrifying shapes, adapting to very specific environments and diets. These prehistoric reptiles living 200 million years ago remain a great mystery to modern humanity.
Dinosaurs in the early Jurassic are one of the most fascinating things about Earth's ancient past. At that time, the supercontinent Pangaea began to break apart into separate continental blocks. Shallow seas gradually filled the gaps, and the continents slowly took the shapes we recognize today. The bays deepened and separated Africa and Australia, creating new marine pathways for life to spread. While the distance between Africa and the Americas also widened, changing global ocean currents and climates. In Eurasia, low-lying areas like Germany, England, Paris, and Spain, Siberia were being formed. The Arctic Ocean also flooded the northern coast of Laurasia, creating new northern sea environments. In North America, the Rocky Mountains and the Andes Mountains began to form through tectonic pressure. The separation of tectonic plates was accompanied by intense volcanic activity, releasing massive amounts of CO2. This increased the greenhouse effect, making the climate in the Jura about 5 to 10 degrees warmer. The CO2 concentration in the atmosphere was 4 times higher than it is in the present day. Rainstorms during this period were also more frequent and intense compared to the late Triassic. Earth at this time had a tropical and humid subtropical climate, supporting vast green landscapes.
Large areas were covered by lush vegetation, mainly dense jungles and large tree forests.
The dominant components of the flora were seed ferns and various types of non-flowering woody trees.
Unlike animals, plants were luckier because there is no clear evidence of a mass plant extinction.
Thanks to high temperatures and humidity, trees in the forest grew very tall and large. Cycads were a common type of tree in tropical and subtropical regions during the Jura. Their golden age began in the Jurassic and Cretaceous periods, reaching a peak in diversity.
Cycads, also known as sago palms, have a shape very similar to modern palm trees.
The famous botanist Carl Linnaeus even made a mistake in classifying them into the palm group.
However, only one species of ginkgo still exists today, which is the Ginkgo biloba.
Along with cycads and ginkgos, prehistoric conifers also developed strongly during this time. At the end of the Triassic and early Jurassic, they changed rapidly and became more diverse. In East Asia, Podosamites, an extinct conifer species, was the dominant type of tree. Unlike most modern conifers, Podosamites had broad leaves like regular trees and shed them seasonally. The rich vegetation created favorable conditions for the explosion of the animal kingdom, especially insects. There is no sign of insect extinction during the transition from the Triassic to the Jurassic. Therefore, the forests, grasslands, and riverbanks of the Jura were filled with diverse insect life.
Imagine predatory dragonflies hovering over the water to search for their next prey. Herbivorous beetles gathered in tree clusters, while spiders and scorpions ambushed their prey nearby. In addition, there were some creatures that looked like modern butterflies, but were actually different. This is explained by a miraculous evolutionary phenomenon called convergent evolution in nature.
Actually, they belong to another group of insects, most closely related to modern lacewings. At that time, flowers had almost not appeared, only small ones not yet adapted to insects. However, gymnosperms like conifers with cones containing nectar attracted these fake butterflies.
Convergent evolution is a phenomenon where unrelated species evolve in the same direction to adapt. That is why unrelated species can look exactly the same, despite living in different areas.
A typical example of convergent evolution is the tenrec species found in Madagascar. If you put a tenrec and a hedgehog together, it's hard to find 10 differences.
However, in reality, tenrecs are more closely related to elephants than to hedgehogs.
Similarly, the fake butterflies of the Jura had broad wings and scales like real butterflies. They even had camouflage methods exactly like real butterflies, but belonged to a different group. Such examples show that evolution always looks for the shortest and most optimal path for survival. This also means that if one day we find a distant planet similar to Earth, we might meet strange creatures that look very familiar due to similar environmental pressures.
At that time, amphibians gradually gave way to reptiles, with many species going extinct.
Caecilians, with their legless bodies, adapted to a life underground in the moist Jurassic soil. Among the large amphibians, there were still a few brachiopods that grew up to 3 meters. The record belongs to a fossil found in Lesotho, Africa, with an estimated size of 7 meters. Prionosuchus was the only giant amphibian, but it appeared and went extinct in the Permian. Brachiopods had a flat body and a paddle-shaped head, with sharp teeth in their mouths.
This helped the predator tear its prey apart instantly, making it a formidable hunter in the water.
Although they developed strongly in the early Jura, their numbers gradually decreased over time.
Meanwhile, reptiles developed rapidly, occupying land, sea, and air across the entire planet.
Before dinosaurs split into a separate group, the diversity of reptiles increased rapidly in number. After surviving the mass extinction, they gradually recovered and developed strongly in the oceans. One of the most prominent species was the Ichthyosaurus, also known as the fish lizard. There were many different types of ichthyosaurs, with an average size of 2 to 4 meters. But due to favorable environments, some species reached giant sizes, like the 15-meter Shonosaurus. Some ichthyosaurs had very strange appearances, with bodies like sharks but heads like crocodiles. They could be seen as a weird joke of nature, much like the modern platypus. A notable feature of ichthyosaurs was their very large eyes, protected by a bone ring. This helped them hunt at night and dive to great depths where light is scarce. With an eye diameter of up to 25 centimeters, they had the largest eyes of any animal. The Temnodontosaurus could see at a depth of 1,600 meters, far beyond human capability.
While humans can only see total darkness at 600 meters, these reptiles thrived in the deep.
According to paleontologists, at depths of 800 to 950 meters, light intensity is only 1%. While reptiles occupied the land and oceans, the sky was ruled by the pterosaurs. They could be seen as a weird joke of nature, much like the modern platypus. The long-tailed Rhamphorhynchus continued to develop, mainly eating fish and small animals. Terrestrial reptiles in the Jura became more diverse than ever, including early turtle species. Prehistoric turtles generally looked like modern turtles, but the dominant group was the dinosaurs. In the early Jura, dinosaurs quickly occupied the ecosystems left vacant after the mass extinction.
There is a common prejudice that all dinosaurs were giant. But they came in all sizes.
Some species were only as small as a chicken, while others grew into giant monsters. Most dinosaurs were carnivores, hunting prey to survive in the harsh prehistoric world. While some herbivorous species moved slowly, stepping on the ground and munching on vegetation. About 180 million years ago, a special herbivorous dinosaur lived in what is now Zimbabwe. This was the Vulcanodon, a species with the typical body structure of the sauropod family. It had thick, pillar-like legs, a long neck, and a long tail for balance. This was one of the first dinosaur species discovered in Zimbabwe, marking an important find. Its Latin name is Vulcanodon, which means volcano tooth due to where it was found. Because its fossil was found in a sandstone layer sandwiched between two ancient lava flows. At the time Vulcanodon lived, the environment was a hot, sandy desert, not very favorable. However, there were still vegetation oases, some rivers, and rare water sources for survival.
Vulcanodon was about 6.5 meters long, 2.5 meters high, and weighed 2.5 tons.
Some researchers believe it could reach 11 meters in length and weigh up to 3.5 tons.
Despite being a herbivore, Vulcanodon could not avoid becoming prey for contemporary predatory reptiles.
Evidence of it being hunted appeared as soon as the first fossil of this species was found. The shape of these teeth is similar to those of predatory animals, suggesting a violent end.
This suggests that the Vulcanodon might have writhed in pain when it was killed by predators, causing its head to fall down level with the pelvic region, a phenomenon seen in other fossils. Because of these strange teeth, This herbivorous dinosaur was named after its own killer's teeth.
While Africa had Vulcanodon, in North America, Dilophosaurus was the dominant predatory killer. Loud dinosaur.
This species lived about 199 to 198 million years ago in what is now Arizona, USA.
This was a formidable killer, with high speed and superior agility, specialized in hunting small herbivores.
The name Dilophosaurus comes from Greek, meaning two-crested lizard, due to its unique head features. Scientists believe these crests were for decoration, playing an important role in attracting mates. Similar to the crests of modern iguanas, roosters, or the basilisk lizard we see today. Dilophosaurus was up to 7 meters long, 2 meters high, and weighed about 400 kilograms. It was the largest predator of its time, often called the T-Rex of the early Jurassic. Despite being dangerous, Dilophosaurus could not easily take down armored dinosaurs like Scelidosaurus, unless they hunted in pairs or packs to overwhelm their larger and more protected prey. For smaller prey, Dilophosaurus was a terrifying predator with long, narrow jaws for quick strikes. It could also eat fish and aquatic creatures, or even scavenge carcasses to survive. Scelidosaurus was a small carnivorous dinosaur that moved on 2 legs, living on the ground. They were up to 3 meters long, with a slender and light body due to hollow bones. This is one of the earliest dinosaur species known in history, appearing in the late Triassic. The name Scelidosaurus comes from its extremely light bone structure due to hollow limb bones. This reptile was common in North America, especially New Mexico, as well as South Africa. Compared to the large Dilophosaurus of the same time, Coelophysis looked much smaller and agile. The teeth of Coelophysis have typical carnivorous features: thin, curved back, and very sharp. Instead of hunting alone, they tended to hunt in packs to take down larger prey. In the late Triassic and early Jurassic, North American valleys were mainly deserts, with some oases. In these areas, Coelophysis packs hunted by chasing and surrounding their prey with speed. Scientists hypothesize they could use special sounds to communicate while hunting in a group. There is a possibility that Scelidosaurus could cooperate to take down larger herbivorous dinosaurs. However, their main diet included small animals, reptiles, and lizards found in the undergrowth. For a long time, they were thought to be cannibals due to fossils found in New Mexico. However, in the early 2000s, this hypothesis was rejected after more detailed research. The small skeleton actually belonged to another species, Hesperosuchus, a contemporary small reptile. This means Coelophysis did not eat its own kind, as previously thought by many scientists.
Ghost Ranch is not only where many Coelophysis fossils were found, but also other prehistoric reptiles.
A natural disaster like a flood or drought might have killed the entire pack at once.
Another small but notable dinosaur in the early Jura was the Lesothosaurus. The name of this species is related to the country of Lesotho in Africa, where it was found. Lesothosaurus lived about 199 to 198 million years ago and was one of the smallest dinosaurs. Lesothosaurus had a body length of up to 2 meters, which is the maximum estimate.
Its height varied greatly, from 40 centimeters to 1 meter or even more.
Lesothosaurus moved on 2 long and strong legs, allowing it to reach incredible speeds. The five-fingered front limbs of Dilophosaurus were small, but well-developed for grasping. Thanks to these front limbs, Dilophosaurus could touch and hold the plants it ate. The diamond-shaped teeth of Dilophosaurus were arranged in rows along the jaw for cutting. This structure was ideal for cutting soft plant stems or leaves in the lush forest. The long and strong tail helped it maintain balance while moving quickly through the undergrowth. Dilophosaurus was a very agile animal. At any sign of danger, it immediately ran away. But did it have any enemies? Of course, at least the predatory Coelophysis species. When mentioning typical prey for Coelophysis, Dilophosaurus perfectly fits this list. Another small but very interesting dinosaur was the Lycorhinus, with many strange features. The name Lycorhinus comes from Latin, meaning wolf face, due to its sharp fangs. However, the rest of its teeth showed it was an omnivore, eating both plants and animals. Lycorhinus lived in the early Jura, about 199 to 196.5 million years ago, in South Africa. It was about 1.2 meters long, 50 centimeters high, and weighed up to 10 kilograms. Its front limbs were well developed and could be used to grasp plants while eating. The skull of Lycorhinus was drop-shaped, with a hard beak like a bird's in front. Right behind the beak, it had large and sharp fangs for tearing through tough food. Initially, scientists thought Lycorhinus was a descendant of the mammal-like reptile group Cynodontia. But after more analysis, they realized Lycorhinus was an omnivorous dinosaur species. Its diet included succulent stems, ferns, horsetails, and even small insects or animals. Despite having sharp fangs, Lycorhinus was not a formidable predator itself. Only its speed and camouflage ability helped it escape from larger predators in the forest. In East Asia, specifically Yunnan, China, there was a giant herbivorous dinosaur called Yunnanosaurus. Yunnanosaurus was up to 13 meters long, 4.3 meters high, and weighed about 3 tons. In the early Jura, Yunnanosaurus was considered a large dinosaur compared to others. It moved on 4 legs but could also stand on 2 legs to reach high branches. A special feature of this species was its 60 spoon-shaped teeth in the jaw. These teeth were ideal for tearing through tough leaves and stems in the Jurassic forest. The early Jurassic was a time of great diversity and evolution, shaping the future of life on Earth.